All right, we're going to work through the homework here, the page 8 assignment for P1. And 1, 2, 3, and 4 wanted you to match this equation to its graph. And so what we want you to do is to become familiar with what you see and identifying what kind of a function this is, what kind of equation would this be. So for number 1, hopefully you would look at that and remember slope-intercept, that this is going to be a linear equation. It's going to create a line for you. And the only one that did that was B. And that line has a y-intercept of 2 and goes down 1 over 2. So just bringing back something that hopefully is familiar to you from previous class, right? Number 2, that would probably not be as familiar. You'd look at that and you probably don't remember too much about something like that. Now, the good news is if you ever get confused, if you're not really sure what you're doing, you can always kind of put some numbers in and see. In fact, this one we're going to graph later on in number 50. But the idea is that if you look at your options, maybe you want to skip this one because this was multiple choice. We'll come back to this in just a second and do it more in number 50. Number 3, we see we have an x squared. Anytime we see x squared, we're thinking quadratic, we're thinking parabola. You look at your options, the only one that had a parabola was A. And that parabola, because of this negative, opens down, and the 4 is your y-intercept. So you start up at 4, and you have this parabola that opens down. And then number 4 here is a cubic equation, and then you look at your options, the only one that had a cubic look was C. And with cubic equations, we're kind of expecting this a function that kind of comes up and maybe does a little wiggle here and then continues up. Or if that was a negative in front of there, it'd be coming down and then do a little hesitation and then continue, something like that. So we have A, B, and C covered. That means this obviously has to be D. And again, we'll talk in number 50 a little bit more about how we could have gotten that look there. All right, come back to that. Number 20 and 24 wanted you to find x and y intercepts. Now, y intercepts are the easier. All you have to do is put 0 in for x. So if we were to put 0 in here, we would get 0, 0. Y squared equals 0 means y would be 0. If we put that in an ordered pair, it means 0.00 is your y-intercept. X-intercepts are a little bit more difficult. In those, we're going to let y equal 0, and therefore we're going to have to solve the equation. So if I put 0 in for y, I'm going to get 0 equals x cubed minus 4x. If I pull an x out, this is going to give me x times x squared minus 4. And then if I break that down, I'm going to get x times x plus 2 times x minus 2. So there are 3 things that x can equal to make this 0. Could be 0, could be negative 2, could be positive 2. And so all of those act as intercepts. So if you were to graph this out, you would see this thing intersect the x-axis at all 3 of those spots. Again, it's a cubic equation, so we kind of expect something like that. The y-squared presents a little interesting thing on that, but these are our intercepts for that. Okay. So for 24, same idea. For my y-intercept, I'm going to let x equal 0. So if I were to put 0 in for x, I'd get 0, 0. And down here, I would get 1 squared, which is 1. So 0 divided by 1 would still be 0. So the 0.00 is still my intercept on that. For the x-intercept, I'm going to let y equal 0. And that gives us this. And this can look pretty intimidating at first. And might make you feel like, well, I'm not sure, I don't know how to handle stuff like this. So the good news is this. When you have a rational function, a fraction like this, and you're trying to solve it, really, to get it to equal 0, you only have to concern yourself with what would make the top equal 0. Okay? That would be your solution. If the bottom equals 0, this is what we call discontinuities. We're going to talk about that more in chapter 1. So we're not really concerned. If the bottom equals 0, then that's not in our domain. We have to throw that value out. And so we're just really going to concern ourselves with the top. So when does x squared plus 3x equal 0? If you pull an x out, you're going to get x times x plus 3. And so that's when x equals 0 or x equals negative 3. Those are your 2 possibilities, and so those will be our x-intercepts. All right, and so that's how we would find those. So again, we're just going to become comfortable. Some of these things can look a little intimidating, but as you have a little understanding, they simplify and they become very manageable for all of us. Numbers 39, 44, 50 wanted us to graph these, and so again, I would hope that you would have a good memory about this. You would say, oh, there's my y-intercept of 2, and it has a slope of -3, so I go down 3 over 1, and you make kind of a rough line like that. Okay, linear equations shouldn't give us too many troubles. If it's been a little bit of time, it should come back to you pretty quickly. A quadratic, again, is something you should expect that U-shaped graph. This is a positive, so it's going to be opening up. And +3, if I put 0 in for x, is our y-intercept. So if I go to the y-intercept and then have it be U-shaped from there. Again, I don't have to do too much. I don't have to make an XY table if I don't need to. If I have a good idea of what these things look like, I can kind of sketch them off of there, which is helpful. For number 50, again, this is the one where probably we don't have as good of an idea of what's happening here. And so you might want to create a table. You might want to put some values in. So if you put 0 in for x, you're going to get the square root of 9, which is 3. So when x is 0, y is 3. And then you might say to yourself, well, when would this equal 0? Well, that would be if x squared equaled 9, and that would be when x equals 3 or -3. If I put 3 in there, I'm going to get 9 minus 9. If I put -3 in there, I'm going to get 9 minus 9. So when x is -3 and when x is +3, I get 0, right? And you can play around. You can put 1 in there and 2 in there and kind of see what you get. The big key is to understand that if you were to put something less than -3 in there, you're going to have a problem, right? Say you put -4 in there, you're going to get 9 minus 16. That's a negative, and we can't take the square root of a negative. We're not going to deal with imaginary numbers in calc, which is a good thing, so you don't have to worry about I or anything like that. So we can't have anything less than -3, and we can't have anything greater than 3, because both of those would cause a problem in there. So we don't worry about that. Now 57 gave you the option of putting this on your calculator, so we want to be good at doing this on the calculator. Assuming again that we'll be back together and take a regular AP test, they expect you to have a firm handle on how to use your calculator. So for us, we have y squared minus x equals 9. Now I can't make this y squared, but what I can do is take, add this x and take the square root, and I would get y equal to the square root of 9 plus x. And so if I put that in, square root of 9 plus x, and I'm going to go zoom 6 just to put it in a standard window. I can see what I get here. I get 1, 2, 3, 4, 5, 6, 7. It looks like at -9. So way back here at -9, the graph starts and then kind of makes this kind of curve right there. Okay? Now, one thing to note here is that when we added the x and then took the square root, technically this could have been the positive or negative square root of that. All right? So I would also want to include the negative square root of this. And if I graph that, you're going to see that it matches it down below. It gives us a little partner here. And so what happens is because the y is being squared, this is a parabola that's actually just been turned on its side. And that's what happens every time we square y but not x. All right, so it's similar look to this, it's just been turned over. All right. One thing that we're going to get comfortable with in here is using some shortcuts and whatnot. So if I wanted the negative version of y1, what I could have done is gone negative and then do alpha trace, and you'll see y1 pops up right there. If I hit enter, now I can use y1 to represent this whole thing, and I end up getting the same thing. So there's the original graph, and then there comes the mirrored image of it right there. Right. Again, we want to get comfortable with that. The more shortcuts, the quicker you can use your calculator, the more time you have to think through your AP test and do well on it. All right. All right, 64 then wants us to find points of intersection, and so what I'm going to do is I'm actually going to solve for x here. I don't want to put x minus 1 in here and have to FOIL it out. That seems really cumbersome. I think a better way to do this is to let x equal y plus 1 and put that y plus 1 in for x right there. And so I get y plus 1 equals 3 minus y squared. Then if I add this y squared over and subtract this 3, this should be 2. I end up with y squared plus y minus 2. That factors into y plus 2, y minus 1, which gives me y equal to -2 or 1. So those are my y coordinates, and now I'm going to put those back in. Probably right there is the easiest spot to see what x is. So when y was -2, x would be -2 plus 1, which would be -1. When y is 1, x is 1 plus 1, which is 2. There's my points of intersection. If you put the x minus 1 in for here and square it out and do all that, you'll get -1 and 2 for x, and then when you plug them back in, you'll get these y values. So either way works. I just think this is a little bit easier. This one, we're not going to be able to avoid it. Both the x and y are being squared here, so I'm going to go ahead and subtract 2x on this. The idea is to get something by itself first, then take what that equals and plug it in. So if I do that here, I'm going to get x squared plus 10 minus 2x squared equals 25. Now I'm going to have to FOIL that out, so I'll just do that kind of quick. 10 squared is 100. You're going to get a -20 and another -20, which will give us -40x, and then -2x times -2x is a +4x squared. All right, put that together, I get 5x squared minus 40x, and then if I subtract this 25, it'll be a 75 right there. Now, luckily, everything is divisible by 5, so we're going to go ahead and divide everything by 5. And then that's going to factor into x minus 3x minus 5, which gives us x equal 3 and 5. So there's our x values for our points of intersection, 3 and 5. Now I'm going to plug those back in, and again, probably here's the easiest place to do that. So 10 minus 2 times 3, 10 minus 6 is 4. Put the 5 in, 10 minus 10 is 0. And I could try those out here. 3 squared plus 4 squared is 25. 5 squared plus 0 squared is 25. And so we end up with our points of intersection there. And then the last one, number 70, wants us to do that on the same thing, but do it on the calculator. So we get ourselves a little bit of a break there. So I'm going to go to y equal and type in x to the 4th minus 2x squared plus 1. All right, so there, but you can see I made a classic mistake on purpose just to show you that you want to be careful with how you put this in. It was x to the 4th, then you got to come down, and now minus 2x squared plus 1. All right, and then for the other one, we have 1 minus x squared. Okay, so I'm going to graph that, and what we'll see is the x to the 4th first, and that has a little kind of almost W look there, and then we have this parabola. Now, it looks like it could be intersecting in lots of points right here. It's kind of hard to say, right? So we really need a window that just goes right along here. Now you can go to window and change it. It looks like if we go from, say, -2 to +2 for the x, and maybe -2 to 2 on the y, maybe we'll get a little better look. So here's our x to the 4th graph, and then our quadratic is going to come up. And now we get a little better idea what's happening. It looks like it intersects here, here, and here. Let's make sure. If I go second trace, hit intersect, I'm going to come over by the first one, hit enter, 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 and it gives me -1, 0. So there's 1 point. If I go second trace, intersect, and I go up to the top point, I'm kind of anticipating it'll be 0, 1, but just to be sure. Now you can see that it went over to this one and gave me 1, 0. So I'll put that down. And it's possible that I may not get this because they're touching and they don't quite intersect, or they don't cross through each other. It's possible that the calculator may not give me that one. But if I hit trace and put x equals 0, it goes to 0, 1 for the y1, and then when I push up for y2, it's also at 0, 1. So the calculator may not be able to tell me that's an intersection point because of it not crossing through, but we can clearly see that they both hit at 0, 1. So that would be a point of intersection as well. All right. So again, play around the calculator. Don't be scared of it. You need to be proficient at it, and hopefully you felt pretty good about what we did here today.